Elliot, Dominik, Max. Great.
Far. Okay.
All right, okay. I'm Anna Tong. I work at Forbes and I cover AI, and I've also been covering the humanoid robot revolution as well. Just gonna ask everyone to quickly introduce themselves and what they do, starting with Elliot.
Hello, everyone. My name is Elliot Helms, and I'm an advanced solutions engineer at Novanta in the robotics and automation group. And Novanta develops components and sub-assemblies for OEMs in the advanced industrial and medical spaces.
Hi, everyone. I'm Dominik Boemer. I'm a manager at FEV Consulting. We have been working together with leading humanoid OEMs this year. Right now, we are mostly focusing on also getting the ecosystem rolling. This meaning we are helping a lot of suppliers to actually get into the humanoid market right now. We do not only do pretty slides, but we also do this in the real world. So meaning we have been working with the Hugging Face project on there. We have our own robot that we are working with, and essentially 6,000 engineers behind us also.
Hi, my name is Max. I'm co-founder of RemBrain, and we transforming off-the-shelf robots into computer vision-powered line workers. We are a bit controversial because we here in Humanoid Summit with under humanoid. It's very simple box with arms on top, specialized on manufacturing tasks.
What's that?
Is that going to be in here?
Yeah.
Oh, okay, yeah.
Okay, great. Let's start with I want to start with some quick lightning questions about predictions, since we're talking about roadmaps to commercialization. All right, when do each of you think we're going to get a real working humanoid in the home?
I would say we will see demos of that next year.
A real working one?
Real working in the home, I would say 6 years.
Okay, Dominik?
Yeah, I think this sounds quite reasonable. I think it also depends on what we call a real working one. It depends essentially on the use cases. And I think there's also this concept which I called evolution of use cases. Obviously, we will be focusing mostly on the use cases that are technically feasible. And well, this is the same problem that we also have with AI. What is work completely? I think this is not a 0 or 1 solution. This is a continuum.
I was made the first driving from San Francisco to LA in Tesla in 2016, and most of this drive was on self-driving. And I was thinking like, okay, in 2 years, probably Uber will fire all of their drivers and stuff like that, but it didn't happen. And it seems like it's not going to happen soon. And it was 9 years past. And we have very, very good self-driving, but it still have some questions and problems. So I think that cost of error with humanoid robots at home is less than while driving, but the task itself is much, much more complex. So I definitely don't wait this tomorrow or the next year. I would agree with about 6 years of timeline for like relatively working humanoid robots.
All right, what about when are we going to get our first humanoid that will work a full 8-hour shift in a factory without falling over?
If battery technology and actuator technology continues to improve at the present rate, I think that's reachable within probably about 3 years.
Yeah, and I mean, we are also still tripping, so a robot could also still fall in the future. So as long as it is not completely destroyed afterwards, I think we would still buy it. So therefore, I think this will continue to be something that might happen, but the important part is that the fall is essentially safe and does not completely destroy the robot.
My point of view that we sticking to humanoid form factor too much. We will probably talk more about this later, but I think that in the factories, it's all about efficiency. And efficiency means that maybe more specialized robots. It's even with humans, it's about the same. Like somebody can do very tiny operations, somebody can lift very high, like very heavy weight. And with robots, we will do even more variability. Some robots will deliver, some robots will assemble. and factory is where specialized robots are going to shine. And I think that humanoids will do only tiny layer of tasks in factories in the future.
Okay, that leads me to my next question. When are we going to get our first factory that's only humanoids?
I would say probably 10 plus years, 10 to 15 years. And a lot of that has to do with the unique value that humans provide and the value that humanoids provide. And there will be certain things that don't necessarily make sense to replace with automation, tasks that humans still add value on, and that a generalized human won't necessarily be able to achieve at a reliable or cost-effective enough scale.
I think that 10 years is also quite reasonable. And the funny thing is that you did not mention, are these actually humanoids or other robots? Because I think there are already quite a lot of factories that actually operate without humans, or at least only humans that are there on a very marginal basis, only like have with the support functions, but the main work is actually done by AMRs right now in some factories.
Yeah, I agree on the timeline, but I also see that we will have not only under humanoids, but I would say over humanoids. So some robots that will be over our possibilities. Let's say for manufacturing, it's useful to have 4 arms instead of 2 arms. It's useful to have 360 view instead of just 2 eyes looking forward. And I think that because we will chase efficiency, we will see very interesting things, especially in factories.
Okay, all right, I'm done with my quick questions. So we are talking about how we are going to scale humanoids, and I'm hoping that someone can give me an overview of what that will look like. So help us paint a picture. How do we get from where we are today, which is some cool demos, to a lot of humanoids operating at scale, and what does that journey look like?
Yeah, I think there are essentially 2 very important concepts. And the first one is what I typically call the evolution of embodiment. I really like these humanoid companies that are also focusing on the mobile basis, on the wheel basis, because I think it is really important to adapt to the technology or what the technology can currently do. So I think it's really important to start typically from a humanoid arm or a arm, then put that arm on the torso, put the torso on wheels, and then finally put the legs below it. Because you could then implement it depending on what technology is actually available. And at the same time, you also have the evolution of use cases, meaning that you would obviously start with the use cases that are technically feasible and then increase it more and more based on what is also available in terms of data that has been collected, which was a predominant topic during the summit.
From my point of view as a component and subassembly manufacturer, I think, as Anna, you pointed out, right now we're seeing a lot of demos that relate to agility and meaning the ability to move dexterously or quickly and react quickly. But really, I feel over the next several years, maybe 3-year timeline, we're going to see what I would call a right sizing of actuators. So understanding what is actually needed to perform the tasks. And I'm a firm believer that the industrial space, so automating in the logistics, warehouse, factory space, makes the most sense as the beachhead for introducing humanoid robots gradually into our workforce. And so in line with right sizing, I think that we will understand what aspects of the hardware are important, specifically safety, cybersecurity, and performance, and how will we essentially collapse or commoditize on a few important parameters and perhaps drive value through those in high mass production, but have essentially a collapse of the proliferation of technology that we're seeing today.
Thanks. Another point of view that maybe we could divide all of the robots into 2 categories. First category is where you have to very efficiently do some tasks. Maybe it's not a big list of tasks. And the second category is where you have to be able to do thousands of tasks, but efficiency is not a key. So first category, it's about manufacturing. Second is more about homes. Like, for example, robot can clean your house overnight if he will be silent enough. And it's not a big question how fast he will do this. Like if he will spend the whole night trying to put some things into trash bin, it's okay. So I think that humanoids are much more suitable for this category of tasks where efficiency is not the key. It could be kind of home routine tasks that people want to give up. And I think that we will see more applications of robots in this kind of environments. And only then we will go to some kind of high efficiency things where like manufacturing or something like this.
So you were talking about cybersecurity, Elliot. Can you tell us about what are some of the cyber concerns that you have about humanoids, and what are some of the issues that are going to need to be solved? I'm assuming you're talking about people hacking into humanoids and making them killer robots.
Yeah, absolutely. So I think that in general, humanoid OEMs are thinking carefully about this problem from the system point of view. And it's true that as we deploy more and more hardware into the field, you're increasing, let's say, the surface area of a potential cybersecurity attack, more chances for a bad actor to get in and perform some damage. And what we're thinking about, again, as a subsystem provider is how do we harden our actuators, for example, or our drives against potential attacks? Because maybe the high-level humanoid has the AI in place or the high-level software stack that it's not going to be susceptible, but let's say someone pushes a firmware update that causes an uncontrolled motion in one of the actuators. That could be just as devastating as if you lost control of the top-level humanoid. So we're thinking about things like safe boot, cryptographically confirmed firmware updates, and also access control based on role in the organization. And we feel that's an important thing to take into account, especially given the climate of improved focus on cybersecurity through the Cyber Resilience Act, as well as the European norm for the protection against corruption of machinery.
I mean, here we are talking about cybersecurity, and I think what's quite interesting is that you probably know of one of these very well-known humanoid companies who is actually not that safe as of right now, and so far nobody has actually been hacking them, at least at any conference. So far we're at least safe from that perspective. I think we will be talking later on also about functional safety, which I see as an even more important issue right now, at least in the current situation.
About 15 years ago, I surprisingly found that one of the easiest way to, it was very kind of common to go into some closed infrastructure through webcams. So webcam was surprisingly bad in terms of cybersecurity. It's fixed over the last 10 years, but imagine a robot could have a lot of additional interfaces, and maybe it's a good thing to go through inside. But in fact, robots are just computers with a couple of motors surrounding them and sensors. So I don't feel like it's going to be way different from a laptop or any other devices. But functional safety is definitely more important than cybersecurity safety.
Okay, yeah, let's talk about functional safety. Maybe Dominik, you can start. So, I mean, I know, Figure AI was sued by one of their former head of safety over, and I think in the lawsuit said, this robot almost basically swiped someone and then put a 1/4-inch gouge into a stainless steel refrigerator. So, I mean, how bad of how much of an issue is safety, and what's the safety roadmap going forward?
Yeah, I think we can start with that roadmap. So, as most of you probably know, right now the solution is essentially to use work cells. The robot is behind a light curtain, and once you enter the space of the robot, well, it then moves into a safe state. One could also then consider to be the next step that the robot has actually dynamic safety zones. This means if you get closer to the robot, it would, for instance, get into a state 1, which is a state in which it does not move that much anymore. And if you get really close to the robot, you could go into a safety state 2, where the robot would then completely stop moving, or in the worst case, simply melt down. I think I would also hand over the question to Elliot, because I think there are some very interesting safety or functional safety techniques that are currently being developed.
Yeah, absolutely. So we're very invested in supporting the community and participating in efforts like ISO 25785, Part 1 for actively controlled stability of robots for things like bipedal robots. It's something we take very seriously, and we are actively developing hardware that supports what we think is one way of addressing where we expect the standards to be going in the next 3 years. So that's something, if you're interested in speaking about, we would love to connect with you on that. We feel it's very important. We had the honor of hosting the last meeting of the ISO committee in Barcelona, so very excited to see where that goes next and how we can cooperate with OEMs to make sure we're providing the right solutions and enabling humanoids to work around humans.
Yeah, maybe one more interesting point on this functional safety again. I believe that we have to go to over humanoids. So like we as humans do not have 360 awareness view. We do not have some support device, or we cannot kind of close ourselves when we falling down. And I believe that some of those things should be in humanoids to kind of make them safer, like 360 view or 360 degrees awareness could be one of the important things for robots that impossible for humans, and this type of stuff should make them actually maybe even more safer than humans on the manufacturing or doing these routine tasks.
Okay, Max, I think you already touched on this a little bit before, but do you have anything you want to share about kind of like the evolution of form factor? So you were saying right now you feel strongly that it should be 2 arms on a box. Like how does that form factor evolve?
Yeah, very good question. Thank you. And I have a dream that I would write a book someday, like what if human will be designed by engineers, how it should look in this case. And I realized that maybe we as humans are not the most optimal thing, let's say not the best design in the world. So I was just thinking and dreaming like, what if I would have rollers on my feet? It's great, I can roll around, and when I need to walk stairs, I can break them and walk. Second, I would be happy to have tail. I can use it in some useful ways. Or imagine I can have 4 arms, or I can have cameras on my palms to take a look under the sofa to do something. Like, it's interesting that I think that we shouldn't lock ourselves to kind of very limited form factor and industrial design, and we can go way beyond, and that's the answer.
I would say that I agree with this. I, however, think that there will be a natural progression in this. This is also what I mentioned earlier. I think that it is really important to start with these humanoids on a mobile platform, then the bipeds, and then I'm expecting suddenly more and more customization to the specific use cases. Because what we're also seeing is that why are so many companies interested in humanoids? Simply because we have built, as Jensen usually said, the world for ourselves. And therefore, as of right now, well, obviously the human form factor is the form factor that can be used in most of the scenarios. However, as we usually try to optimize systems, well, I'm expecting this then to be the next optimization, meaning humanoids that are or augmented with more than just 2 arms, for instance.
I feel that Pras from Agility always does such a great job kind of setting expectations for bipedal humanoid robots. And really what I heard earlier in his talk is we design around what is necessary. If bipedal locomotion is not necessary for a specific solution, it's not going to be the best solution. So I really appreciate the sentiments that each of you shared and understand that there will be a variety of form factors and embodiments of humanoids, be they legged, wheeled, or otherwise.
So you have a magic wand and you can wave it and fix any technical issue now. What issue would you fix and why?
So far, what I found really interesting here during the conference is that we were talking a lot about data and data collection and the quantities of these data. But what I was missing a lot is, well, what are actually the scaling laws? And so far, this seems still to be quite an open research question. I mean, physical intelligence is already showing some of these results. But this is something that I would like to at least know right now. Well, how much data do we actually have to collect until we get all the use cases actually implemented? Can we start well from foundational models and then just fine-tune for different scenarios that we have in there? So this is maybe not directly the answer to what would we change, but this is at least a question that we should answer as fast as possible. And I think we really reached that point at which now we have these big operations going on, and seeing what are actually the results out of this will be very much interesting, I think, for the whole community here.
Yes, very interesting. I think we all want to know, and we want to know how much money is going to have to be spent collecting data.
So on the hardware side, I know that maybe 3 of the most common topologies for rotary actuators are planetary and strain wave and cycloidal. And of course, we see some modifications or spin-offs of those, as well as linear actuators. I'd like to believe that there's still room for improvement, room for innovation on the mechanical hardware side, something that deals with the proprioceptive requirements of actuators while still allowing for a decently higher gear ratio, so that you can channel your motor effectively and not have things like overheating, but at the same time maintaining a low mass. So if anyone has any ideas or is working on that actively, I encourage you continue. I think there's still overhead for the perfect solution out there that could be adaptable to different parts of the robot.
For me, the main thing we have to do is like decrease amount of complexity to have robots released not in 5 years and 10 years or like next year, tomorrow. And I also believe that we will develop a specialized type of robots. We can have big robots, small robots, fast robots, accurate robots, and we of course we work in the manufacturing robots, so it's special type of things specialized on like repeatable operations, but humanoids will be different. So I think that like kind of we probably will. It's like an analogy, maybe the closest analogy is in cars. So we have different types of cars, like we have big trucks, we have luxury sedans, and they all coexist. They all have different functions, and kind of defining all of this and understand what we actually need here, what we actually need there is important, even after we go through all of the technical hurdles.
What do you think is going to be the harder problem to solve, the software side of things or the hardware side? And under software, I'd put the data issue.
I think that software side is more complex, and like there is a lot of different things how we can address, like how we can address software problem, because what do we see right now? Hardware is extremely stable. I think that we still have more gaps into sensing type of hardware maybe, but software is the thing we have to address. Maybe we have to wait for next paradigm. We just have transformers as one of the main type of AI models now, but maybe for humanoids we have to have much more, because current transformers, they have to have extremely high amount of data to be accurate. I know that, Dominik, you can share more in numbers. I agree with this. but there is some type of robots that do not require a lot of data to be useful right today. Again, like I'm talking about our company. In our company, we can reach 99.5% of success rate in some production operations with much simpler models where you can show like 5-6 samples and it's going to work. But overall, I think that software is the biggest complexity.
So I would agree with that with software. However, I think there are still some very interesting challenges on the hardware side. So the companies that we have been working with, and obviously which have then their end clients, which are automotive manufacturers or warehousing companies, the warehousing companies and also the automotive manufacturers, one of their problems is actually battery life. So they have been in the past, so there are some companies which had 2 battery packs in there, and then suddenly after the pilots, they had suddenly 3 in there, simply because they wanted to increase the uptime. So I think this is also something important. It's something that I tried to address earlier in the question is also reliability of the systems. So we have seen that Figure Robot, which was for 5 months at BMW in Spartanburg. We have seen that AGI bot, which has been walking from, I think, Shanghai to a different city, so several tens of kilometers, if I remember it well. So this are, although obviously for the introduction, the software is the challenge, but later on for a very economical use of these robots, the hardware is also a very important one, and also lightweighting so that the use time actually becomes long. Obviously, there are also solutions like battery swapping or inductive charging, and there's also not yet a real convergence on that. But I think there are also still some hardware problems that absolutely have to be solved.
I am biased, admittedly, but I feel that hardware, specifically dexterous manipulation hardware, is going to be the next frontier as far as unlocking potential of humanoid robotics, assuming that's right for the application. So I'm very much looking forward to grappling with that challenge over the next 10 years or so.
All right, I think we have time for maybe 1 or 2 audience questions.
Hello, everyone. Thank you so much. I was a bit disappointed with one statement that one of you said, that humanoids will be for domestic usage and they will be not efficient enough like the actual robots to perform other tasks beside the domestic. I'm in the food industry and I really target the humanoids to be in the restaurants, to be in the canteens, to be in the fields where the big machines, the current robots, cannot fit, but fits a humanoid. So please don't let me go out of this amazing summit with that feeling.
We want names now. I'm not sure who's actually said this. I think we would all agree that well, as Nick Redford also said, well, we have these 3D use cases still, so dirty, dull, dangerous. I think they are still, so this is not only domestic, I mean, there are a lot of commercial use cases. Maybe I misunderstood the question, so please, Elliot, Max, also help me on that one, but I have the impression that we should really not only focus on the domestic, so the home use case, but also definitely on the other use cases.
Yeah, I was said that I have to go other way, right? When I was saying that, I was thinking about sequence, and not that we shouldn't avoid humanoids in other industries, but my view is that humanoids closer to our human body form factors will be more likely at home, because on these situations where we have to work close to heavy machines, we probably will drift away from our humanoid form factor. And it's gonna, that was the idea. So more humanoid robots will be at home and less humanoid robots will be in heavy manufacturing or something. So we definitely I don't think that we shouldn't go with robots in other than home industries.
All right, one super fast question, and then we'll wrap up.
So of all the things that we have to conquer, there's this assumption that the cost is just going to come down. You know, people are making these wild marketing claims, 20 grand humanoid for the home. I can't buy that. 100, 150, 200 grand for a robot. Cost. We will see, in my opinion, no real takeoff in this space until we do something seriously about cost. And that seems to be kind of just floated over, in my opinion.
Yeah, I appreciate you saying that. I think maybe that's where I believe that industrial automation, manufacturing, logistics make the most sense, because you really need to provide a meaningful use case, and we also need to be able to produce at the right manufacturing volumes. We can bring all of the components in a car together from many, many different suppliers and do that in a timely manner and at an economical rate to allow consumers to purchase it. I think probably decades from now that could make sense as far as bringing the cost down for home use, but certainly I feel that's why the industrial use case is going to make more sense in the short term.
All right, I think we are out of time now, but thank you all.
Thank you, guys. If you want to just return your mics at the back.